I now want to show you how to apply liftoff nodes to a structure so that you can accurately model those situations where you have tension fabric in contact with your rigid members, but it's not firmly fixed, so that when wind or various other forces come along, if that fabric would want to lift off from that structure in real life, we can accurately model that in NDN. Let me first quickly show you the current state of our model. So I'm going to turn off the rendering. Right now, I have everything divided up into layers, and we have a total of 9 layers. Then for load cases, we have a total of 5 load cases. We have our load case number 1, which is pre-stress and dead load. We have a snow load case for load case 2, and then we have several wind cases. We have, for load case 3, we have wind hitting the structure in the X direction, then we have the XY direction, and finally the Y direction. If we zoom in on the trusses, you can see that we have our membrane elements connected to the top of our truss just like you normally would, which is exactly what I want up until now, up until the point of applying my liftoff nodes. The first thing we now want to do from the model environment is come down to offset N, which stands for offset node, and click that button. This opens up the options of how you can apply offset nodes to your model. We have several different choices. We have vector offset, arc offset, or surface normal offset. For this example, since I have a nice arc truss structure, I'm going to go ahead and select arc offset, and I'm going to select a distance that's the equivalent to half of my member size, which would allow you to have your fabric resting right on the top of your rigid member. This model is in US units, so just for an example here, I'm going to put 0.125 feet, which would be 1.5 inches, which would effectively be saying that the top of my truss is a 3-inch diameter circular section. So once I have that, this is actually a pretty busy model. So before I go ahead and I start applying these, I'm going to turn off my membrane, I'm going to turn off my struts, and turn off my cable. So basically I've turned off everything except for my beam elements. So now I'm going to come in and click Assign, and I'm going to assign by string. Now, one important note to remember when assigning by string in NDN is that NDN will always try to pick up the shortest path distance between two nodes. So for example, on this truss structure, if I want to apply my offset nodes across the entire length of the top, I'm probably going to have to do that in multiple strings so that NDN doesn't accidentally jump down to the bottom section of my truss trying to create that shortest path distance. So for this example, I want to apply my offset nodes along the top of my 2 center trusses. So let's start with the back truss, and let's say I want my offset nodes to start at this point. So let's start our string here. Let's run that to about here. Okay, it highlights it. I like that path. I'm going to right click, and then you can see that it went ahead and it generated a second node, the distance that I specified, so it's given me my offset node. So let's continue this across the top of this truss. So I'll zoom in a little bit. I'll start on my next node. We'll come to about here. That looks good. Right click. Let me adjust again. Go to my next node. Come to here. Good. And then let's do the last couple right there. Okay, I've got my first truss. Now I'll just start on my second truss. Okay. Looking good. Okay, let me do my last little section here. There to there. Okay, perfect. I'll do a zoom extent. So I now have my offset nodes set across the top of both of my 2 middle trusses. Now, what's really handy, if we go back and we turn all of our element types back on and zoom in here, you can now see that NDN has automatically gone through and it's taken all of my membrane elements that were originally connected to the top of my truss. It has now connected them to my offset nodes. So everything is now ready to go as far as changing the geometry of the structure. NDN has gone through and done the bulk of that work for us. Now, if we go back to the model environment and we click on our layers, you'll now see that 2 new layers have been created. We started with 9 and we now have 11. So these 2 new layers are our master nodes layer and our lift nodes layer. If we go to layer 10 here, our master nodes, if we zoom in, you can see that those are the original nodes we had in the model, the nodes along the top of our truss, and the lift nodes are now the new nodes that have been created, those offset nodes that we just added. So NDN has gone ahead and done that for us automatically. I can click Finish. I'll do a zoom extent. And now we simply need to tell NDN what we want our new offset nodes to be. And for this case, we want those to be liftoff nodes. So to do that, we just come into the property environment. We'll click on Node DOF for node degrees of freedom, and then we will select the liftoff button. In here, we can assign our new offset nodes to be liftoff, slide and lift, or lay against. So for this example, I'm going to select liftoff, and then I just need to assign the layers to the corresponding boxes here. So for the first box is our liftoff nodes. So I'll select the drop-down menu, and I'll select layer 11 for my liftoff nodes. They get highlighted. The next box, label master nodes. For that, I will select my master nodes layer, layer 10. They get highlighted pink. I can go ahead and click Finish now. However, real quickly, let me mention what's going on up here at the top. First of all, this says for load case. This means that my liftoff nodes won't actually go into effect until load case 2, which is perfectly fine because remember, load case 1 always pre-stress and dead load. Also, iteration 3, when using the liftoff features, it's best to let NDN run through a few iterations to see which nodes want to lift away from the structure before it starts adjusting the model. We found that 3 iterations is pretty appropriate. So I'm going to leave these as the defaults. I've got my layers assigned appropriately. I can click Finish. And now we simply go in and run our analysis. So I will hit back. I will come down to the analysis. I'll do a real quick check data. Model data has been checked, no warnings or errors found. I'll go ahead and click Analyze. I'll leave this set for 200 iterations. I know each load case will converge below that. Leave everything else set as the default. I'll go ahead and click Go. You can see we're running through load case 1. All right, we're into load case 2. Now load case 3. And you can see as it's going through these load cases, our liftoff nodes are getting highlighted in this red. And then once they lift away from the member, that highlight goes away to indicate that they are actually lifting away from the steel. We're in load case 3. Okay, into load case 4, and again, right there, you could see about half the structure lifted away as soon as we hit that 4th iteration where NDN is allowed to actually have the model lift apart. Okay, load case 4. Okay, onto load case 5, and again, we've got liftoff occurring again in load case 5. So this will be done in just a second. Perfect, we're done. Let me show you the post-processor display results. And let's show the deflections here, and that'll actually show our liftoff. Load case 3, perfect. This is where you can see the center. If we zoom in here, you can see that it's lifting off across the entire center of the structure, especially if you put it in a side view. And then you can see, matching the color of the arrows, we've got about 13.6 inches of rise happening in the structure there. Let's go ahead and look at load case 4, load case 5. Again, yeah, you can see the center of the structure is allowed to lift off. The ends are still connected to the truss, and that is liftoff nodes.